Exercise 4.7, question 13. In this question we are told that A, B, C, D is a parallelogram. And when you're told that it's a parallelogram, you can basically just say that opposite sides are parallel. So AB is parallel to DC and AD is parallel to BC. That is from the definition of a parallelogram. We are also told that BD is produced or extended, so BD is extended to E, so we say BD is produced to E, and DB is produced to F, such that DE equals BF, and those are indicated by the little dashes on the diagrams. In part A, we have to show that angle FBC, that's this angle here, in there, is equal to angle ADE. Now, just remembering the only information that we've really been given is that ABCD is a parallelogram. So we know that AD is parallel to BC and AB is parallel to DC, and this is the only information that you can use. So because we can only use that we've got some parallel lines, we should be looking for either co-interior, alternate, corresponding angles. And I think the best type that you can see here is if you can see that backward Z, that we can use alternate angles. So if we let, just say this angle down here, angle DBC equal alpha, then this angle in here, which is angle ADB, will also equal alpha because AD is parallel to BC. So let's write that up first. So we're letting angle DBC equal alpha, and I've just put that in on the diagram. And hence, and we can see our alternate angles there, and hence angle ADB is also equal to alpha. The reason, alternate angles, AD is parallel to BC. Now in the back of the textbook it actually says AB is parallel to DC, which is incorrect. When you form that Z, the parallel lines are basically what forms the top and the bottom of the Z. So our parallel lines are AD and BC. Now looking at the question, we have to prove that FBC is equal to angle ADE. Because we know the angles that are adjacent or next to those two angles that we're talking about, angle FBC would just be 180 minus alpha because we have a straight line there, and angle ADE similarly would be 180 minus alpha because we have a straight line here. So we're just going to write those both up. So angle FBC equals 180 minus alpha in there because we have adjacent angles on the straight line FBD, and similarly angle ADE just here is also 180 minus alpha because of adjacent angles on the straight line BDE. Hence therefore we have shown that angle FBC, that one there, is equal to angle ADE, and the reason is that they're both equal to 180 minus alpha. And I've just marked those 180 minus alpha angles on the diagram. Now in part B we have to prove that triangle FBC is congruent to triangle EDA. Now already we can see that we've got equal angles here. The 180 minus alphas are equal. We can see that DE equals BF, and we have a parallelogram here, so we can say that length AD equals length BC. So we're going to write that all down now. So first step, angle FBC equals angle ADE, which was proven above. Then we can say that BF equals ED, which has been given. And the last bit of information is that BC equals AD because the opposite sides of a parallelogram are equal. Hence, we can see that we've got a side, an angle, and another side that are equal. Therefore, the two triangles are congruent by side angle side, SAS. Okay, I've also just marked in those equal sides on the parallelogram. In part C, we have to prove that ACFE is a parallelogram. Now, there are 4 different tests that we can look at to prove that we have a parallelogram. Because we've just proven that triangle FBC and triangle EDA are congruent, we'll try and use information from that to help us with this proof. So we're basically going to look at AE and FC. Now, one of the tests for a parallelogram is that if one pair of opposite sides are equal in length and also parallel, then it is a parallelogram. Now, because we know that these two triangles are congruent, we know that AE equals FC. So that shows that we have the opposite, one pair of opposite sides equal. We need to also show that these pairs of opposite sides, in other words, that AE and FC are also parallel. Now, because we have two congruent triangles here, we can see that this angle here, angle BFC, is opposite the double dash side. And in this other triangle down here, that angle AED is opposite the double dash side. So angle AED is equal to angle BFC because they're matching angles of congruent triangles. And because we know that those two angles are equal, we can say that they're also alternate, and hence AE is parallel to FC. So we're going to write that all out now. So I've marked these matching angles on the diagram. So angle AED is the matching or corresponding angle with BFC in this other triangle. So we can write that up first. So we've got that angle BFC is equal to angle DEA. Reason is that they are matching angles of the congruent triangles that we just proved that are congruent. We can also look at the positions of BFC and DEA and note that they happen to be alternate to each other. So these angles, if we do our backward Z, are alternate to each other. Therefore, we can state that AE is parallel to FC because alternate angles are equal. So we've just proved that AE is parallel to FC. The last thing that we need to prove is that AE is equal to FC. Now, those two sides are opposite the 180 minus alpha angles, so they are corresponding sides of congruent triangles. So I'm just going to mark those in. So those equal sides have been marked in with the triple dashes. So now we can write that up. We've got that FC is equal to AE because they are matching sides of congruent triangles. Therefore, that is enough to prove that we have a parallelogram. So our final line, we can just say that, therefore, AFCE is a parallelogram because we have one pair of opposite sides that are equal and parallel. And that is the end of the proof.